Scientists often dismiss philosophy as mere armchair speculation, but the scientific method itself is rooted in philosophical principles. Three major philosophical insights, contributed by Francis Bacon, Alan Turing, Alonzo Church, and Noam Chomsky, have directly led to advances in the practice of science. These insights have had a significant impact on how science is performed.
Philosophy is often mocked by scientists as little more than armchair speculation. Stephen Hawking famously declared it dead. This is unfortunate because the scientific method itself is a manifestation of philosophical thought arising from the subdiscipline known as epistemology. Historically, science and philosophy have worked hand in glove to advance our understanding of the world. In fact, science went by the moniker natural philosophy for much of history. Advances in social and political philosophy helped prevent some scientists who upset the established order from being executed. But that's a discussion for another day. Here, we will examine three philosophical insights that directly led to advances in how science is performed. What makes science different from everything else is inherently a philosophical question. That means that philosophy helps define what science is. This is important because, to learn about the world, we need to be sure of the validity of our methods. For most of the history of Western philosophy, Aristotle's ideas reigned supreme. While Aristotle's idea of finding causes through science was largely based on deductive reasoning, experimentation was not seen as a vital part of science. Modern computing is tied to philosophical attempts to determine what mathematical problems could be solved. Alan Turing advanced one solution to the problem in 1936. His world-changing paper has the cumbersome title On Computable Numbers, with an application to the Entscheidungsproblem. From this paper, we get many bold ideas, including Turing's thesis, which says that, given enough time, anything that can be represented as an algorithm can be computed. Importantly, he argues that a universal computing machine could do this in place of humans. Less well known is that Alan Turing wrote his solution to the problem immediately after his doctoral advisor, the mathematician, logician, and philosopher Alonzo Church, wrote his own thesis on the subject. Church's version is the lambda calculus, a method that can simulate all other methods of calculation. The thesis is essentially the same. He also found that anything that can be calculated by a human or a machine using similar processes can be solved in a finite number of steps that can be expressed in a limited number of symbols. In the mid-20th century, many dominant ways of thinking about the mind and brain focused entirely on behavior. Schools of thought, such as behaviorism, centered on human responses to stimuli and punishments. This theory lost credence after Noam Chomsky wrote his first book. He overthrew the behaviorist model by pointing out that children were not getting enough examples of language in their early years to explain how quickly they learn. Instead, he took an approach similar to that of the rationalist philosophers.